up, guys? Mr. Lidkea here. Today, we are going to talk about exploring the faces and edges of 3D shapes. Okay, so 3D shapes. A little different than the two-dimensional objects that we were talking about before, so I'm not going to use the board to teach this one. I've got my trusty 3D props set up already. Let's first talk about parallel edges. Now, what is parallel again? That's right. Parallel lines are two lines that are always the same distance apart and go on and on forever without ever touching. Now, what I have here is a rectangular prism, okay? You can see, obviously, that we have a rectangle shape on all sides of this object. So that's why it's called a rectangular prism. We're going to look at a few other shapes in a minute. What we have here are two parallel edges highlighted in red. These two edges are always going to be the same distance apart and they're never going to touch. Obviously, there's more examples of parallel edges on this shape. This edge and this edge are parallel. If we turn the shape, this edge and this edge are parallel. This edge and this edge are parallel. For another example, think about the room you're sitting in. The two walls on opposite sides of the room are parallel. They will never intersect, okay, unless they're tilted on some sort of angle. If you're sitting in a rectangular room, and that's a good thing to think about, is any shape that has a rectangle on it is going to have parallel edges, okay? Now, let's talk about perpendicular edges. Perpendicular, to review, are two lines that meet at a right angle. You can see that I've added in the little square down here to show that this is a right angle. The red edge and the blue edge of this face are perpendicular. We also know that if we have a rectangular shape, we've got four right angles. So that means that all of these edges are perpendicular. This edge is perpendicular to this edge. This edge is perpendicular to this edge. This edge is perpendicular to this edge. So in this shape, on this face of this object, we've got four different perpendicular intersections. Any shape, any object that has a rectangular face is going to have perpendicular edges, just like we have right here. If I turn this shape on its side, we can see again, I didn't highlight these ones, but this edge and this edge are perpendicular. Okay, let's look at some perpendicular and parallel edges from some different objects. Here I have a square pyramid. We can tell it's a square pyramid because of the shape of its bottom face. If we look at this shape, we can think which sides are parallel and which sides are perpendicular. Now, you can see that I've again highlighted the parallel sides in red. These two sides are opposite of each other and they will never meet. They'll always be the same distance apart. Again, I've highlighted the perpendicular side of this object, red over here and blue over here. And then I've drawn another square to show that we have a right angle in this corner, okay? We again know that being a square, we've got four different right angles. So that means that there's four different sets of perpendicular sides. This side and this side, the top and this side, the top and the other side, and then the bottom and the other side, okay? This shape is a triangular prism. Now, what we have to do is imagine that this side is filled in, okay? This face right here is a triangle. So we know that we have a triangular prism. It doesn't meet at a top point like the pyramid, so that's why this shape is called a prism and not a pyramid. And it's also got rectangular sides, okay? So let's talk about our edges. Parallel edges, again, highlighted in red. The top edge and the bottom edge are parallel, okay? These two edges would also be parallel because they're on opposite sides of a rectangle, they'll never touch. Now, again, the red and the blue represent a perpendicular edge. The square drawn down here shows you that we have a right angle. We, again, knowing this is a rectangle, know that there are 3 other examples of right angles and perpendicular edges. Let's switch gears and talk about the faces of the object now. The faces are just the flat areas that make up the object. This is a face. We have a face up here, we have a face down here, and a face over here. Obviously, every flat side surface of this object is a face. Now, let's talk about parallel faces, okay? On this object, the faces that are opposite, such as the top and the bottom, the 2 sides, and the front and back, are all parallel sides. These sides, just like the edges, are going to be the same distance apart, and they're never going to touch, okay? Now, just like in the room that you're sitting in, where you have 2 walls that meet, whether it's the floor and the side wall, or the 2 walls meeting in a corner, you've got perpendicular faces. So this top face and this front face are perpendicular because they come together to meet, okay? If we were to draw, we could put a cube in between there and we would see that those are square, just like the square that we have down here. So the front face and the side face meet at a corner, so those are perpendicular. Same on the other side. We can also think of this in terms of horizontal and vertical, okay? When we're talking about horizontal, we were talking about the horizon, the lines that are straight across, okay? When we're talking about vertical, we're talking about up and down, okay? Now, we can also have vertical edges, vertical faces, horizontal edges, and horizontal faces. Let's look at some of the horizontal faces on this object. The horizontal faces are the ones that are flat to the horizon, or in the same flat plane as the horizon would be. So the top edge and the top face and the bottom face are horizontal. Okay? Now, all of these other faces that are facing up and down are vertical. Okay? We can turn the shape. This is a vertical face because it's straight up and down. This is a vertical face, straight up and down. This is a vertical face. Okay? So in this example, we've got vertical parallel faces, which are the 2 on either side. And we've got vertical perpendicular faces because this one and this one are perpendicular. This is a little confusing. You might want to grab a cereal box or something like that so that you can manipulate it around and see for yourself how this works. We always talk about the shape as it's sitting on a table or whatever, a desk, as it is in this case. Okay? So we can say that the horizontal face and the vertical face are perpendicular. Okay? And that's the same for all sides. We've also got 2 horizontal edges and 2 vertical edges. Let's look at a few more examples of parallel and perpendicular faces on different objects. Here is the triangular prism again. Now, we know that we've got a triangular face on this side, a rectangular face on this side, triangular face, rectangular face, and so on. Now, let's look at the faces that are parallel. Which 2 faces on this object will never ever touch and always be the same distance apart? That's right. The 2 triangular faces will never touch because they're on opposite sides of a rectangle. Okay? This face over here and this face over here are always going to be the same distance apart. So they're never going to touch. Now, we could describe this as having 2 parallel vertical faces because this face is pointing straight up and down. Now, there's a difference between this face and this face. Because it's a triangle and it meets at a point, this face is not vertical because it's not straight up and down. Yes, it's going up off of the desk, but it doesn't go straight up and down. If I tilted it on its side, then it would be vertical, but it's not sitting straight on a face, okay? Let's talk about the horizontal faces of this object. The bottom edge that sits on the desk is horizontal because it's in that same plane as the horizon. Also, we could say that this edge is horizontal and this edge is horizontal. This shape does not have any vertical edges when it's in this position. If I turn the shape into this position, however, now we've got a horizontal edge on the bottom, and we've got a vertical edge going straight up and down. So you can see that the object will change depending on its orientation, or the way we can describe it depending on its orientation. That means which way it's sitting, okay? So now, the horizontal faces of this object are on the top and the bottom because they're in that horizontal plane. Horizontal edge, horizontal edge, horizontal face. Here's the pyramid again. When we look at the pyramid in this orientation, we don't have any vertical faces. None of the faces are pointing straight up and down. They all meet at the point at the top. But we do have a horizontal face and edge. The bottom face, the square piece, is laying flat. So that plane, the horizontal plane, is the horizontal face. And then we have horizontal edges along the side. Today we talked about the faces and edges of different 3D objects. We talked about parallel edges. Those are the ones that run opposite each other, always the same distance apart. We talked about perpendicular edges. Those are the ones that meet at a right angle, usually corners of a rectangle or square. Parallel faces. Those are opposite faces, just like the opposite sides or opposite walls in your house. They go up straight, always the same distance apart. We talked about perpendicular faces. Those are the faces that meet like your floor and a wall, or two walls at a corner. We also talked about horizontal faces and edges. Horizontal faces and edges are the ones that are flat along the desk or parallel to that, right? We also talked about vertical faces and edges, and those are the ones that run straight up and down. Think about goalposts on a soccer goal or uprights at a football game. If they're straight up and down, those are vertical. We always try to look at the shape as it's sitting on a desk, okay? Great job today, guys.